So these are the answers to exercise 2 on 5.2, but I'm only going to go through question 3. The rest of the answers you'll be able to just read from the answer sheet. So in question 3, you're asked to write the formulas of a number of different ionic compounds. I'm just going to go through how to do that. So if you look at the first one, sodium sulfide, you've clearly got sodium in there. You've also got sulfur. You need to know the charges on those ions. So sodium is in group 1. Because it's in group 1, it will have a plus charge. Sulfur is in group 6. Because it's in group 6, it's going to have a 2 minus charge. The charges in an ionic compound must cancel. At the moment I've got +1, I've got -2, they're not cancelling. When they don't cancel out, the kind of foolproof way of doing it is take the number and cross it over. So the 2 that is next to the sulfur will come down next to the sodium, and the 1 that's next to the sodium will come down next to the sulfur, and that gives me Na2S. Okay? The other way to think about it is I've got 2 negative charges, I need 2 positive charges, therefore it's going to be 2 sodiums and 1 sulfur. And you need to use subscript, so below the line. Okay, if I wrote that as a big 2, the same size as the sulfur, I'm not going to get the mark for that. Cesium bromide, cesium, CS, I think. Cesium, yes, CS, is in group 1, so it's also got a 1+ charge, just as sodium has. Bromine is in group 7, and it has got a 1- charge. So in this case, my charges do directly cancel. When they directly cancel, no numbers are needed, and I just get CsBr. Magnesium nitride, I've got magnesium in there. Magnesium's in group 2 with a 2+ charge. Nitrogen is in group 5 with a 3- charge. 2+, 3-, these charges are not cancelling out, so I'm going to need to cross over my numbers. The 3 comes down next to the magnesium, the 2 comes down next to the nitrogen, and I get Mg3N2. Okay, it's really important that when you're writing your final answer, you do not include the plus and the minus. Okay, your answer should include your symbols for the elements, and it should include a small number with no charges. It's fine to use the charges to work it out, but your final answer should not include charges. The next one, I got chromium 3 oxide. Okay, so chromium is not in one of your main groups. So with your main groups, if it's in group 1, it's +1. Group 2 is +2, +3, -3, -2, -1. So if they're in the main groups, you can just look at the group to see what the charge on the ion would be. Chromium is not in the main group, okay? So you will be told what charge is on that chromium ion, and they do that by using Roman numerals. You've got a 3 in brackets, which means it's going to be 3, but is it going to be plus or is it going to be minus? Well, chromium is over here. It is a metal, and metals always lose electrons, so always form positive ions. Therefore, it is going to be 3+. Oxygen is in group 6, so I use my periodic table, and I see it has a charge of 2-. Again, these charges aren't cancelling, so again, I'm going to cross over just the numbers. I'm going to get Cr2O3. Next one, tin chloride. Again, tin is one of my transition metals. It's got the symbol Sn. Because it's a metal, I know it's going to be positively charged ion. Because there's a 2 in Roman numerals, I know it's going to be 2+. Chlorine is in group 7, always has a negative charge. These charges don't cancel. I cross the number over, and I get SnCl2. Okay, I don't need to bring the 1 over. You can, you won't lose a mark, but it's just not normal. Nickel 2 selenide. Nickel, again, transition metal, symbol Ni. The 2 tells you it's going to be 2+, always plus because it's a metal. Selenide comes from selenium, which is here in group 6, so it has a 2- charge. So that's Se with a 2- charge. 2+, 2-, these charges immediately cancel. No numbers are needed, it's just NiSe. The next one is aluminium oxide. Aluminium is in group 3 with a 3+ charge. Oxygen's in group 6, 2- charge. Those charges don't cancel. I cross over my numbers, Al2O3. Copper 1 iodide. Copper is a transition metal, so it's always going to be positively charged. The 1 tells me it's 1 plus. Iodine is a group 7, it's minus. Plus 1, minus 1, these charges cancel, no number is needed. CUI is my answer. As I said, the rest of the answers you can find on the answer sheet, but if you do have any questions about them, just message me to ask.